Professor Suzana Yusup. She is a principal researcher and head of section under Fuel and Combustion Generation Unit, Department of Generation and Environment, Tenaga Nasional Berhad Research, a subsidiary of Tenaga Nasional Malaysia, the electric utility company in peninsular Malaysia. Her last position in academia was as professor at University of Technology Petronas prior to joining TMBR, teaching both at undergraduate and postgraduate levels, as well supervising master and PhD students. She receives her PhD in chemical engineering from University of Bradford, UK, a Master of Science in Chemical Engineering from University of Wales, UK, and Bachelor of Engineering in Chemical Engineering from University of Leeds, UK. Her research interests include biomass conversion to fuel and value-added products, green processes, and material development. She has more than 25 years of experience in academia and research. She is a fellow of Academy of Science of Malaysia under Engineering and Science discipline, fellow of International Bioprocessing Association and senior researcher fellow of Resilience Development Initiative, and a registered professional engineer of Malaysia, a chartered engineer and chartered scientist of UK. She's actively participated in consultancies projects with industry and research and development projects nationally and internationally. She published more than 200 articles in various international and national journals, seminars, patents, book, chapters, workshops, and conferences, with total citation of 15,600 and an H-index of 68. Her research work has been honored with awards nationally and internationally in recognition of her contribution. I think this very important topic of biomass, which is coming because we need renewable carbon in future systems for feedstock fuels, is a very, very important one. And Malaysia is a country rich with biomass and rich with biomass history of how to improve its use. So please, the floor is yours.
Yeah. Okay. Thank you, Prof. Navin, for the presentations and introduction. So I'm Suzana. So I want to share today on the biomass value chain for the energy transitions. So as we know, there are going to be three scopes of my presentations. First, I will talk about the motivations. What is the drive? What is the global and national target? And then I'll go through on the biomass value chain perspective, specifically in the energy transitions, and then I will share about our case studies. Okay. So we see now current, we see people are talking about climate change, the increasing CO2 being emitted. So we see that more initiative strategies need to be done in order to in order to prevent increasing rise of temperature and further to prevent emissions of CO2. So here, based on the IPCC report, it says that we need to reduce 45% of these greenhouse gas emissions by 2030 in order to prevent increasing of 1.5 degrees Celsius. So where are we now, right? So now we are 1.1 degrees Celsius above the pre-industrial level. So meaning that there need to be a concerted effort, strategies in globally, nationally, in order to mitigate these emissions of CO2. And then Malaysia also has made a pledge, a commitment to reduce this intensity of carbon emissions by 45% reduction per GDP in 2025, in comparisons by the year 2030. So meaning that from a Malaysia perspective, we have to come up with a roadmap strategies in how we can move forward to support this initiative. And in the Malaysia scenario, the emissions of CO2 is largely in gigagram CO2 equivalent emissions, and energy sector is the largest contribution. So what I'm going to share today is what will be the roadmap of Malaysia and how the industry combined effort to achieve the KPI, and I will share and give some lights on the case study where we are positioning utilizations of biomass as our power resource fuel. Right. Okay. We see that yesterday, today, the talk on policy, right? So actually, when we look into these situations, it can be like a bottom-up approach and also on a top-down approach, right? So when we talk about the top-down approach, the policy is important. We can see that in Europe and US also, there are certain target need to be reduced by certain year. And this is where we can see increase in policy being announced, being implemented, or as well as a law in order to ensure the a target, being emitted. So this is where we can see a global effort and strategy is very crucial to move towards these net zero emissions. And in this slide, it shows that there are many types of sectors where CO2 being emitted. So here we know that energy sector, also the industry, the aviation, shipping, the transportation, these are among the sectors that has contributed to CO2 emissions, right? So here we can see that how the importance of policy in shifting these reductions of CO2 emissions for all these sectors. We can see that more need to be done, especially for the electricity and the heat sector, where you can see that it gains the bigger chunk of the CO2 emissions. And here, with the pledge policies and announced pledge, with the implementations of all this, we hope that globally, in all these sectors, will achieve a reduction in CO2 emissions and move towards a net zero target. Right. So TNB, this is where the company I'm working. It is the Tenaga Nasional Berhad. It is the main utility companies in Peninsular Malaysia. So Malaysia, we have East Malaysia, West Malaysia. So this company is the key, I think the prime player for the utilities for the countries. So the ideas of moving on achieving towards net zero is there since 2016. So the company makes specific target for us to achieve, meaning that by 2025, they are introducing more renewables and their target capacity for the renewables to be deployed. And also the company, they have a subsidiaries where they have a renewable subsidiary. And where I'm coming from, I'm from the research center that support this energy transition journey for the company to meet their strategic directions. And then the target by 2035, because the situations right now, coal is one of our prime fuel that being used to produce the electricity. So then they make a target that by 2035, they want to reduce this emission intensity to 35%. Then how to do that? So meaning that utilizations of coal to be reduced by 50%. So then it prompts to us that what are the alternatives there in order to complement or fill the gap in terms of the fuel supply. So this is where the biomass coming in, because this is one of the approach or solutions that can be offered in a medium term, in the short term, in low hanging fruits. So, and then the long term is to achieve this net zero and coal free by 2050. So this is where technologies is important. So we are exploring various technologies like CCUS and also other technologies such as hydrogen that can move us towards these directions. Right. So as I mentioned, in Malaysia scenario, strategy needs directions, right? So here, the country has come up with National Energy Transitions Roadmap last year. So with this, the government is hope to accelerate, these transitions from fossil-based to the renewables. So they have in place the NETA, they call it, National Energy Transitions Roadmap. Also, there's a National Energy Policy. So with these two governing umbrella, so this is where, back to a questions of what are the sectors that we can further improve, or what are that will move the needle. So here, the energy efficiency is one of it, is very crucial, and also renewable energies into the mix, as well as starting to introduce hydrogens and also bioenergy. This is where the biomass comes in. So biomass also has a will apply in the energy transition levers for the country. And so then, in order to ensure they are clear of the what to do, and they have positioned certain flagship projects. So in the biomass, it is hoped that with the utilizations of biomass, it can create more, industry that will into it, and then will help to increase the job creations. But in order to achieve this, there needs certain enablers. So what are the things that being in place to move this SME into these biomass industries? So there's also a financing and investment where the bank need to know in terms of the the security, the technologies. So, and also they give supports for these SMEs who are going to be into this biomass business. And also human capital and capabilities development is also being given and emphasized, where now more program. This is where the university, the research centers, and the industry need to talk to each other, and then a cross flow of information on what are the expectations from industry, and then the universities can help to prepare the human capital for the future. Policies and regulations also is there to be available, and also to be implemented, and technology and infrastructure support, and also good governance. So meaning that from Malaysia perspective, they see the needs, the importance of moving from fossil-based fuel to this net zero target. Right. So in order to make sure the aspirations and the target is clear, they have put a KPI. For under each target, there's certain KPI to be achieved. In order for example, they compare this KPI in 2018. So now they expect that, okay, by 2040, and these are the target in terms of percentage, with regards to energy efficiency, with regards to the installed renewable capacity, as well as reductions in coal capacity. So here we can see that the company where I'm working with, and it supports the nation aspirations in order to move towards this renewables energy. So at the end of the day, three important items are being considered. That is, to address the energy trilemma in terms of affordability, sustainability, and also energy security. So these are the pillars that helps to shape up the directions for the nations, right? So we have come to understand that biomass, it can be convert to value-added materials. So we need the technology. So this is where chemical, mechanical engineers, and the scientists can come up with the technologies, be it thermal-chemical conversions, or it can be a biological conversion. So all these technologies are important, but at the end of the day, when it comes to the industry, the key question they will ask, okay, what will be the dollars, and what are value returns to them? So at the end of the day, being from the academy now shifting to the industry, I can see these are very important points that we as the researchers need to have in our back of our mind. At the end of the day, a dollar and cents matters. So there's many technologies there. Examples, when we want to convert biomass to fuel, also biomass to other chemicals, we can leverage on the nature of the biomass itself. From lignocellulosic, you can convert it to make bio-oil. So bio-oil you can make to produce fuel, also from gasifications, you can convert to make a syngas. So these are all the bio-based, products, right? And liquefactions technologies there, where if you think about the liquefaction routes, means that you can handle biomass that is rich in moisture content, right? So it helps to reduce your technology costs in terms of biomass, conversions route. And in our case, we are the case studies that I'm going to share is related to combustion, because like in the utilities industry, this combustion concept is very important, because they convert the coal, to the combustions and to generate certain energies to get tin of certain quality, right? So I'm going to elaborate on these aspects of case study later. And in terms of the biological, because we know that biomass, you can tap upon the lignin base and then the hemicellulose, the cellulose, right? So meaning that there's a lot of business model that you can, derive from the biomass itself. Like examples in the cellulose and hemicellulose base, you can convert it to a biochemical, or you can also, tap and make it to a sugar-based product, right? So meaning that there are many offerings that biomass can offer. It's just that at the end of the day, we have to think about the dollar and cents when we want to bring our research to the market, right? And this slide just to emphasize and share with you that in the energy transition roadmap, so we are happy. For me, I'm happy that biomass also has been declared, as one of the key initiatives for the nations. And also they are open for new technology demonstrations and also new technologies development for the country. Right. So in terms of renewable energy capacity mix, so what is the target? Because like I shared with you just now, there's a strategic roadmap. Okay, there's a point where they need to achieve certain target. So in terms of the biomass, the biogas, you can see here, they are targeting to achieve in 2025 about 333 megawatt. And this value is expected to increase to 406 megawatt. So meaning that this is where various technology enhancements, can be contributed in order to help our national target. And biomass itself, the pie is also increased from 862 megawatt for the power generations, and they are targeting it to be 998 megawatts. So, and then it begs to us as an energy company, how we're going to help them to realize this. So this is where a lot of research and assessment been done in order to ensure that the biomass qualities that we're going to supply to as a co-firing initiative meet the target, because we know that the design of a boiler is very, specific with, to cater different types of fuel. So this is where the research comes in here, right? Okay, so this is where I, just to give some insights, where in Malaysia, there's many agriculture. So, yeah, we have lots of palm-based tree, we have cocoa, we have sagu, right? But the main key resources that we have is palm-based, where you can see in this picture here, okay, this is the fresh fruit bun, okay, from the tree. Then they, once it's ripe, then they press it to get the oil, right? Then it get a palm oil. And then once, because it is in a bunch, so once they have separate the fruits and then the empty bunch, this is what they call is the empty fruit bunch there. So as I mentioned just now, the lignocellulose biomass, right? So this is where can be tapped from here. So various technologies has been explored where they convert this biomass to produce the bio oil. And then inside here, you can see the fruits. So the fruits here, they got the kernel. And this one also they press to get the oil. And this is a very high quality oil, right? And then, but you still have a shell outside here. So where it can be utilized, after it has dehulled here, you can see this is the palm kernel shell where it can be used as a fuel, to generate the electricity, right? But at the end of the day, it's a price because like the situations right now, right? When you talk to SME, they opt to, sell outside rather than use inside. So this is where the carrots need to be there, right? Because like how you prevent these resources from going out the country and yet still have, supplement the energy supply that the country needs. So that's a challenge there, right? So here, and then once you have pressed these fruits, right? When it's been pressed there, you get this byproduct. So this is called the mesocarp fiber. So this is also can be turned into a source of a fuel, or sometimes they upgrade it to make other products, so these are the advantages that we can harness from the biomass. So you can see that among the plantations of agriculture in Malaysia, this palm-based, win 89.8%. So this is our majority agriculture's product. So this is where we trying to leverage upon, right? So right. So how is the situations there in Malaysia in terms of the mill industry, how many we have, and how it is being distributed, in the East and West Malaysia. So you can see here, right, where I'm coming from here is West Malaysia, and then we also have East Malaysia, Sabah, and we also have Sarawak there. So, so if you compare between Sabah and Sarawak, so each of them has a certain number of mills and also certain numbers of productions, right? For from the mill, right? So here in Malaysia, when we compare to East Malaysia, the Peninsula is still, a large contributor for this palm oil industry. So all in all, so this is where this biomass just now can be recovered. Yeah. Okay. Right. So as I mentioned, when we talk about biomass, one of the other thing is a business model, because in the working committee, in preparing for this national roadmap, so they also have, put the thoughts that how are we going to position, is biomass 100% for the fuel, or how are we going to prioritize with a high value added commodity, right? So this is where they put, they do a study, actually, whatever we have when they want to, turn the biomass to a business model, at the end of the day, dollar and cents is important. So examples, if biomass to be used to replace fuel, to replace coal, so at the end of the day, the price of it, the ceiling price is a coal price, right? So in order to make this business attractive, they need to give us this window, it's lower than that. Then we can see the added value of introducing this biomass as a fuel. I know the quality is there, the pricing is there, and then it won't damage our boilers, because it's very important, right? Because if our boilers is not operating, then there's a charge cost that the industry has to bear upon. So we are very cautious in accepting this type of fuels to be introduced, right? So back to the biomass value chain. Okay. So to me, when I think about the biomass value chain along the energy transitions, then it makes me think towards the SDG, right? So when I map it against the SDGs, it means that from the feedstock supply itself, we can add value to it. So why I say that? Because like if we don't tap the biomass, what they will do, normally they just like live in the plantations, right? And then it will, rotten there, and then it will emit methane, right? So there's a certain percentage of the EFB you can put on plantation because you want to enrich the soil, right? So, but the balance, what we're going to do? right? So this is where we have to think about, how we're going to utilize this biomass, to add value to it. So this is where, the SDG 12 is very important, meaning that responsible consumptions in productions, means that whatever you produce, we have to, make sure, you treat it, and handle it responsibly, right? And then in terms of now we have the feedstock, right? So how are we going to add value further? So this is where the biomass processing is very important. Like just now I mentioned about the technologies, the gasifications, the pyrolysis, the liquefactions, right? So to me, when we have these technologies being developed by the researchers, right? So you're going to transfer that IP to the industry, right? So when that can be realized, so it means that you are creating more jobs opportunities. So you are, at the end of the day, when the economy is, the circularity of the economy is there, then this, help the GDP of the nation. So this is where I believe that biomass, have this value added to be, offered in terms of the technology itself, where it can support the SDG 9, where it will spur more SME, industry, and innovations and infrastructures there, right? And in terms of scalability, because without having to explore the advantage of biomass, as a fuel, meaning that previously, when we talk about biomass resources that be converted to produce heat, right? This technology is way back, centuries back, right? But then after the technology is being evolved, then scalability need to be there. So examples for us utilities companies, for us to take up, certain megawatts of biomass, is like, yes, we are cautious, but if it can break through and meet our requirements, standard specifications, then the scale is there. So if the scale is there, then you are, value add the contributions of the biomass towards the economy. This is where the current scenario, there's a provisions of 370 megawatt of grid installed capacity of biomass boilers in Malaysia. And then to me, this will help the decent work and economy grow if we met against the SDG, and it helps, to alleviate, no poverty, because you give a job, to the people. And I will share about our case studies where for us it's very important, because every year we have to submit our report to the investor, to our stakeholders. So ESG is very important. So they are, they will see what we do in terms of our initiative to help to reduce the CO2 emissions. And for this, we share a case study that we have done. Yeah. And then consumer. So meaning that along the value chain, from the feedstock up to the consumer, all have a role to play here, and they can tap upon all these positive value that can be generated from the biomass. So example, in terms of, in order for the government to spur this industry, they have give a feed-in tariff quota. So with the feed-in tariff quota, so they have allocated that in hope that, the SME will take up and grow this value chains of the biomass. And in terms of the policy, I'm happy because I've been in the biomass works all my academic career, and now it's almost 20 years plus, and I can see the movement, towards the support, and I'm happy to see there's a national energy transitions, the policy act is there, and they have introduced a feed-in tariff for the renewables. So to me, this is, something good that I can realize, even that, when you do your research at the early age, you for me, I feel like, okay, how or when it can be realized. So now I can see things are coming there. Okay, right. Right, so, with that, I just want to share that this data is very important because Malaysia has to submit a report to, the IPCC report. So we have to declare in terms of our emission intensity. So we can see that Malaysia has achieved this about 1 million emission reductions based on 1,868 gigawatt hour renewable energy generated from the biomass alone, from the year 2012 to 2020. So meaning that it's biomass to me, even though it's not the major portions, but it plays a role there. Okay. But as I mentioned, because like when we talk to the industry, right, it's not like, you know, it's just a challenge, yeah, back there. Meaning that, as I mentioned, in order for to convince them, okay, say that you have developed a good research, okay, this is the fuel, the solid fuel that very much close to the coal, yeah, but in order to convince them, it's not that easy, because now I can see this because I'm now at this site, you know, I'm with the industry, because we have to ensure the homogeneity, the stability of the supply, and the, you know, the stockpiling, because like when they want to replace this coal with biomass, you can imagine like tonnage of tonnage, right, needs to be there, and then they cannot afford a day without this fuel being, you know, there. So means that fuel, the feedstock quality is very important. So as a researcher, the young researchers out there that do work on biomass, so these are the things that we have to, you know, bear in mind, that when we develop the solid fuel, we have to know the industrial standards. So straight away, you know that your product can meet to the market, you know, very early. And also on the technology readiness, because we can see that when we talk about biomass, the scale is like below 100, below 200 megawatt, right? So how we can shift this to become 500 megawatt? Because like examples in one of our boilers, the megawatt hours, we need 1,000 megawatt, right? So means that how we can shift and move towards this using biomass alone. You know, it's a journey, but at least I'm happy now. The idea of, you know, introducing biomass as a co-firing is there, okay? And integrations of the value chain, because like this is where the pricing is very important, because those who produce the biomass fuel and need to understand the industry, you know, expectation also in terms of if you sell your biomass, right, at a higher price than what they are, you know, paid now for the coal. So it means that it's very difficult for you to get to the market. And what are the advantages that they're going to have, right? Because at the end of the day, when we talk about utilities business, it's the customer, it's us. Like myself, that I have to pay my electrical bills, right? Then the cost will be embedded, you know, to the bill. So this is very important in terms of cost balance, you know, the production's price of electricity and how you manage your fuel stock pricings there. And the skilled workforce, to me, because like now when we talk about this biomass, is how we can modernize the industry by introducing AI, machine learning, you know, to predict the performance, the behavior of all the unit operations in the boilers, okay, in the furnace, in the turbine, right? So AI and machine learning is very also important, and we need to upgrade our skilled workforce. And I've talked about the fuel pricings, the infra. Yeah, infra is more on the questions that being asked, because like in Malaysia scenario, the utilities, the power plant is certain region, right? And the pump mill is at different region. So now how are they going to optimize this in order for them to give the pricing? They also have considered these transportations, yeah, for this biomass to reach their power plant. So these are the challenge, and more need to be done so that everybody, the player in this value chain, understand each other constraint and can move the needle together. And then awareness on bioenergy potential. Yes, there's there, but we need more. Yeah, and certification of standards, because why I say this, because most of the standards now is referring to the wood pellets, which in terms of the property, the wood pellets and biomass there's a, you know, different nature. So we need this is where I hope more research can be done, you know, in order to develop certification standards that, you know, meet the industry requirement. Right. So, okay, these pictures I have here, this is the pictures where I'm there and somewhere up here, where we do the, you know, co-firing of the biomass. We test it in by the industry, by one of the power plant there, where this is how they introduce the biomass pellet. It's in pellet form So it's been transferred to us in the jumbo bag here, and it's being introduced through this funnel here, storage bin, and it let alone to, to pass through this conveyor belt, and then it will meet there at the mill. So each of the boilers, they have their own mill where they have the coal line, and in here they are going to transfer the biomass line, and then they also have the line for the coal, and then it will mix together in the mill and then be grinded. So for these processings of biomass, they need to achieve certain particle size, about 75 micron, and then only it has to meet certain process requirement in terms of the moisture conditions, because like your mill there, you have to monitor the mill outlet temperatures and what is the mill inlet temperatures, because the moistures of the biomass, it will affect the performance of the mill. At the end of the day, the quality of the fuel that you can introduce inside the boiler. So these are one of the examples where, in universities, we learn about the effects of particle size, about the effects of, optimize the air to fuel ratio. Then as an engineer, this where the test is, these are the real playground there. So, but back in my mind, for those researchers there, so what we are doing, if we reflect back against the 12 principles of green chemistry, right? So this is where, when we have a fuel, that we want to convert it 100%, right? But it's not easy, because the nature of the fuel itself, examples, the biomass, it has certain ash, right? So the ash composition, these are the things that the engineers, the performance engineers in the boiler is very afraid of, because it will affect the tubing, yeah? All those their heat exchangers here. So meaning that we as a researchers, okay, we add value with preventions by using the biomass. At the same time, we help to give some insights how to maximize the conversions, and how we're going to increase their efficiencies of the boilers, right? So this slide just to show you the role of the biomass, that can be used, and introduced in the utilities company. Right, that's the system just now is in utilities company, but in Malaysia, our boilers, we have different types of boilers. So when this boilers is being used in the palm mill itself, so you can see that different types of, when biomass being introduced in this boiler, same. The principles of chemical engineering, optimizations of air fuel ratio is still there, but then you can see the fluid dynamics, the mechanics of it, because due to the different natures of technologies need to be considered. Yeah. Right. So this is where this slide just want to emphasize that when we are dealing with the biomass, the optimum biomass quality is important, because we need to ensure that it helps to improve our combustion efficiency, and then it can help to remove the microbial degradation, because this is where, when we talk to the industry, they will ask, okay, if you were to have the biomass, in our, portions of our coal yard, right? Then how you ensure that the biomass will not degrade, will not be microbial attack, right? So this is where in one, just now you saw the biomass being put in a jumbo bag, right? Then they straight away, right? And in another industry where I visit, because I have to do some testing for their trial burn, this is where they put a shade. They put their biomass, then they put the shade there, and then they allow for certain days only. Because they don't want, because in our country it's a very rainy season, that also have to be considered to ensure the quality is being maintained. And also the calorific value. The CV value is very important, because certain boiler design has been designed to accept certain CV values. So when we want to introduce the biomass, so we have to consider these effects of the CV. In our case studies, we find that you need more biomass to achieve certain CV, specified CV for that boiler, due to this low value CV of the biomass itself, right? And then biomass, in order to reduce the transportation cost, the biomass normally being compacted, right? So that you can store it more when you want to transferred from the point, the industry where you produce it, to the utilizations industry, right? Okay, this slide just want to share with you where they have do some testing. They want to check, okay, what will be, is the fuel, the biomass fuel that being, supplied to them, is it varies so much, right? So they have tested with few plants there, and then we can see that that's why when we do, or when we develop our solid fuel, we have to maintain the quality there to meet certain standards here. At the moment, these are the standards being referred. We don't yet in Malaysia develop our full standards, right? This is, we still based on STM and EN. And then they managed to maintain slight, moisture level, volatile matters, ash. There's a slight deviation, but still acceptable. So this is where a guiding factor in order to introduce the biomass to the boiler. And then, but when we talk about introductions of biomass to utilities company, their concerns is on these compositions. Okay? They know that, okay, you can see that biomass, you have higher potassium, yeah, your calcium, so your magnesium, your chlorine. So how this going to, what is the mitigations? Yeah? How you can give a confidence to them, okay, to accept your biomass, right? So this is where research has been done, where washing of biomass play a role. Meaning that the raw biomass, they wash it, to get rid of the potassium, the calcium just now. And then from here, they find that also the silica content is being reduced, meaning that you get a more quality fuel. So at the end of the day, we have to bear quality versus cost, right? So meaning that, yeah, you can have, a quality fuel. So at the end of the day, the trade-off between these two need to be considered, right? Okay, so I think there's some backgrounds that I've put, shade on. So this is to share about our case study. This is the work that we get sponsored by Justin from Japanese. So this is a collaborative works between our research center, University of Curtin, Australia, Kumamoto University, Japan, and also Chulalongkorn University, Thailand. So these are the group work. So I'm going to present the findings from our group. Yeah. So what we have done here is we do the CFD modeling, because the industry want to have a feelings of, okay, can you show us, okay, if we introduce the biomass, right? So how is the heat distribution? Because they will get a penalty if their heat rate is not as per their power purchase agreement, right? So this is where we try to introduce the CFD to give some feelings on what will happen if they introduce the biomass in their boiler, right? So in principles, as I mentioned, and I showed just now, when you want to introduce your biomass to the boiler system, it can be through on-bed blending, yeah, on-bed blending, because you have a conveyor belt that bring the fuel up to the mill, or you can have in-furnace blending. In-furnace blending means that you have your boiler here, you have certain burner rolls there, so you can introduce certain type of fuel to a certain fuel level there, the burner level. So here in our case here, we are assuming what happened if we introduce the biomass is in furnace blending in one of the burner levels here, right? So when this idea is put forward, right? So the questions from the performance engineers from the industry is, what are the impact? How your biomass will, when you introduce the boiler, will it, give effects to the slagging and fouling, right? So and what about the fineness? Can biomass be grinded, up to a certain grind HGI levels like coal, right? So these are all the questions that we ask, and how our mill going to work, because they are monitoring the mill performance is very important, so that they know that the fuel qualities that they've been fed inside the boiler, won't do so much damage there, right? So in our case study, right? So this is how we introduce the system. So we put propositions. Okay, let's assume. So these are, you have 1, 2, 3, 4, 5, 6, yeah, burners there. And then you have a meal, 1, 2, 3, 4, 5, 6 meal. And then we introduce here meal A for the biomass, right? And then we do this co-firing, and then we want to see what are the extent in terms of the emissions, and then what about the unburned carbon, okay? So this is what we're trying to generate from the CFD. So with that, okay, then we have to map against the biomass quality in terms of its proximate analysis and also ultimate analysis, because from there, it shows us the first things that we know that, okay, the biomass that we want to handle is okay, because we can see the percentage of the ash is lower compared if you are doing the coal itself. So that is our first, confirmations of the fuel quality there. And then from here, we know that the risk that we are taking is lower, because though it has the inorganic materials there, because based on these natures of the percentage, we assume it will give low slagging and fouling, and then low fuel rejection limits. So we are based on this. So from there, we moved, and then we put the assumptions here. Okay, as I mentioned, we are introduced empty fruit punch, palm kernel shell, palm mesocut fiber. What if we are going to blend it, with 20% calorific value? The rest is the coal. We assume it's a bit coal because one of the power plant here, they are using the bit coal. And then from there, we ensure the fineness of the oil palm waste is within the range, same as the coal. And then we calculate how much they need to allow this biomass to pass through per meal. So with this, you can imagine how we can spur the value add of biomass in terms of the business there, in terms of SME there. Because to process, the average processing tonnage per meal is about 28 tons per meal, okay? But for the 24 hours operation, single coal firing, you need about 4,560 tons of single coal. But if you introduce the biomass, you need to make sure your biomass is available. It's about 984 tons of the oil palm biomass waste. So meaning that if this works, it helps, to spur the industry, right? So what we do, so basics, mathematics there, we apply the CFD, where here we use ANSYS and also the SolidWorks. So we do the modeling, and from there, these are the results that we obtain. So the first questions that come to us is that we are monitoring this temperature here. This is very important because this is they call these portions is the nose area where when you introduce that solid fuel, the temperature should be not exceeding this amount. Okay, 100. So meaning that when we check this, it seems that we find that the temperature is a bit higher than, right? So meaning that all palm waste, why it is so? Why is this behavior? We attribute it to the high voltage matter inside the biomass itself. Then, in order to avoid slagging and fouling, this temperature requirement should not be, exceed that. So with this, it seems that we are proposing to them, you cannot introduce this biomass with a bit coal. You have to introduce, you can do this, but you introduce the biomass with a sub-bit coal, meaning that lower CV value. Then you can start to, control this temperature so that it still meets their design limits. So this is one of the findings. So these are the insights that we translate to the power plant. So, and then another parameters that the plant is monitoring is the unburned carbon. So unburned carbon means that, the leftover, if you have not optimized, your combustions in terms of your air fuel ratios, then you're going to have a high unburned carbon, which is not good. Yeah. So in this case study, what our result shows is a good news to them, because that the unburned carbon is less than 6%, yeah, because these are their limits. So we tell them, okay, you can do this with a biomass, okay, because your unburned carbon is lower than 6%. And from there, you can also sell your fly ash, because the fly ash, you know, it must meet the 6% lower, right? So then you have additional income, right? So you can sell your fly ash. If you still co-fire your biomass, you can still have that value added, right? And then we check in terms of the fuel flow, okay? I have that? Okay, okay. So, okay. Then we just, see in terms of the fuel flow and the, how this will impact. And then from this, like I mentioned, when we want to introduce that 20% of the biomass, it's will exceed their operational capacity, like in the green lane, but then their limit is okay, but they have to bear that they are working in this, region that is close to their limit, right? So these are the insights that we share with them. So at the end of the day, with the findings, I think to us, we believe that we have given them some assurance that yes, biomass has a value to play. It helps to reduce their emissions. It helps to reduce their boiler performance, right? So this is more on to gain confidence to them, right? So I think due to time limit, another case study is a similar approach, but then we are testing with different types of biomass. So allow me to just get to the final slide for the other parts, where we introduce different types of fuel, because we want to check whether how different this finding and before, right? So here it also gives a convincing result. So this biomass is a sagu waste. And remember, in Malaysia we have lots of agriculture, palm-based, sagu-based, right? So the sagu-based also have given a positive impact in terms of co-firing, yeah, in the boiler, right? So at the end of the day, my key points here is we are not only doing the monitoring for the combustion performance, our team also doing AI machine learning data analytics with regards to the soot blowing optimizations for the power plant. And also we do some crack detections for the power plant in terms of the smart algorithm. And we do for both coal-fired power plant and also the gas-fired power plant. So I think with this, I hope I've enlightened you on the potentials of the biomass as the value-added new feedstocks in order to, help us to move towards the energy transition bit by bit, and achieve the net zero happen. With that, thank you.
Okay, before I open the floor for discussion, I have my own question. In Europe, we have a problem with seasonality of crop biomass. Is it also a problem with empty fuel, empty fruit bunch seasonality, or it's flat during the year?
I think, it is seasonal as well. But then they make like, a stock availability, meaning that they must to ensure that, there's a stock there, so that it won't, you don't have a time where no stock at all. Meaning,
That type of biomass is going to have chemical processes because it's not dry. So bacteria, if you keep it on somewhere in large quantities, you will get the methanation process.
Correct. So that's why they have to, for that, if you want to make as fuel, then this is where the costs come in, because they have to, storage and fuel upgrading to meet this quality requirement.
Okay. I'm opening now floor for discussion. Questions? Yes, one question there, please.
Thank you for the presentation. ask question about the palm-based is used for the combustion because biomass in the recent years there has been a trend that the like empty and then other like has been used for other components that experiencing having higher values of technology. So, like in ammonia, for example, we also have like palm oil, but recently it's been exported to Japan and Korea because it has economic value for the production. So my question is, it has is Malaysia also facing sugar plants, and what is the anticipation because there is
yeah. Thank you for your question. You're right. So that's why I mentioned this, like PKS, right? You see the price in Japan is higher than the local prices, right? So I think this is where the government intervention is very important, right? What are the carrots that they're going to offer so that they realize that you need to fulfill certain percentage for the internal market. In order to surpass that, then only you can go for external market. So I think government rules and intervention is very important.
Thank you, Ken.
Yes, thanks for the presentation. I have another question regarding palm oil. Maybe that's from my German bubble I'm living in. We have a lot of products advertising that they are palm oil free because of the sustainability of palm oil. Because I mean, we have a lot of deforestation and so on. That is one part of the question, and the other is, I think yesterday Stuart said we have to ask the question. So you presented a case study where we have still a coal power plant, but we use pellets, biomass pellets, whether they are sustainable or not, to use less coal. Isn't it a better option to get rid of the coal power plant and use PV or wind instead of that? So another source for electricity, just changing the system instead of burning fuels, whether they are fossil or biomass.
This is where for our country, right, the energy mix policy is very important because like in certain part of the country, you've got a good solar, you've got a good wind, you have the biomass. So this is in Malaysia. When they put this, they look into a diversification of the fuel resources. So they have put certain portions for the solar as well there. And then biomass is still there because we still have agriculture. So this agriculture is going to have the waste, so we need to do something with it and how we add value. So yeah, if you ask me in the long run, this is where the net zero towards 2050, where we need a clean energy. This is where the hydrogens, can play a role there, and where this green ammonia, which is now at its infancy, right? So we hope that moving forward, this alternative, is firmer and we can move directly. Because from our utility company side, we like it or we don't like it, we have to meet the target, and we are not building any coal-fired plant. And then our last coal power plant is in 2044. So you can see how critical it is because we need to transition our workforce and find the alternative solutions as soon as possible.
And more questions? If your fruit sponge is wet when you squeeze it,
Yeah.
But do you dry it before you use it as fuel in a burner?
Yeah, it has to have certain percentage of moisture, right? It has some temperature. Yeah, so that is only damage your milk. Because you're going to milk, compare your spend to the milk, one of the options, or when you want to reduce it straight to the milk.
Okay. And you have discovered the obvious problem with biomass to increase NOx emissions.
Yeah.
So are they in regulation on NOx in Malaysia?
Yeah. currently we have to meet lower than 600 Brent per cube. So yeah, this is another challenge. So it means that we have to optimize their temperature because it's a thermal NOx. So we went to play around with the temperature inside it's a thermal NOx.
Okay, so you could reduce temperature.
Yeah. Yeah. In order to reduce.
Then you need a completely different burner.
Correct. So this is the challenge they're facing. So yeah, I think this is where the industry needs to know before they take up the solutions there. So.
More question? What Henning was talking, in a way, the biomass is a complicated subject because we want to use it in future for something else.
Yeah.
But today we need to learn how to use biomass, supply chains, how to build them slowly. But later on, we will move that biomass from thermal use towards chemical use, because we will need carbon for methanol production, chemical industry, etc. So it's not an easy, at least for me, I'm not a chemical engineer, to see when this transition from combustion towards feedstock for biomass carbon will happen. It's already starting to happen in Europe. Have you considered sustainable aviation fuel?
Yes, for example.
Okay. Yeah. So which of the pathways, chemical pathways, are you considering in Malaysia for SAF?
I think SAF more on the catalytic conversions.
Catalytic.
Yeah. Okay. So you're going to leverage on the oil. In what I presented here is on the solids. So that we can also recover from the oil to SAF. Or if you're going to go through the gas route, so again, it's comparative on which technology set. But
if it's oil based, edible oil, palm oil, then it's. I think it's European legislation does not allow oils to be used. Only waste biomass.
Yeah.
So I don't know.
Then they need to go through the bio oil route.
Okay.
Yeah. That's a possible. Then you do the catalytic cracking. But then at the end of the day, the energy has to balance back. Yeah. But if the oil, because when you process the biodiesels, right, you can still have the distillate that is a byproduct.
Okay.
That you can leverage on that. Also, other types, but not in Malaysia because palm oil, when you process it, right, you're going to get the oil that you can convert to the biodiesels, and also you can also, when you process the biodiesels, you can get the distillate. Yeah, so that one is not byproduct and non-edible. So yeah, there's another routes that you can follow. Yeah, for this.
Okay.
Yeah.
Any more questions?
Yeah.
Yes, Michael.
It's to do with land utilization.
Yeah.
As you do your biomass analysis, are there other competing uses for the biomass or the land, say for food?
Yeah.
Transport fuels.
True. Yeah.
And how to get all that balanced? Do you have enough land?
Yeah.
Across the whole country for the system to fully sustain?
Yeah, I think that's right. That's why in our country, Malaysia, they have put like a certain land to be reserved to what? So means that now for the palm industry, they have gone to their optimum. So means that they have to make use whatever the allocations of the land that been given to them. So this is how the country manage the land use, so that we want to have this balance of utilizations. Yeah, correct. Yeah, they have that.
Okay, if no further questions, we have to end this session. Thank you very much.
Thank you. Thank you.